Our group's name is Echo Mind by Alex Liu, Ho Yu Jung, and Jim Ning. And we did the ChatGPT text to speech, speech to text prompt. The technologies that we use include on the client side, we created an iOS app and we used Xcode and coded it up in Swift. And then on the server side, we used C++ to handle all the client to server queries as well as the server to ChatGPT API queries. And then lastly, we implemented Google Firebase for our user authentication and login. Our main functionalities include, on the client side, include user authentication, connecting to the server, monitoring network performance, speech, text to speech, and speech to text, and TLS TCP socket communication with the server, as well as the ability for a user to view their profile and sign out. On the server side, we implemented POS IX multi-thread connections so we can host multiple clients. We support TLS and TCP socket communications with clients, and we handle interactions to ChatGPT's APIs, handle JSON requests and parse JSON responses, and we forward all our responses to the client. The two protocols that we implemented include TCP and TLS. With TCP, we have our typical three-way handshake where it's just a ACK kind of interaction between the client and the server, and all messages are not encrypted. And then with TLS, we have we exchange application information with encryption. And we use certificates to make sure that the parties on both end are secure. And the benefit of using TLS is that our interactions between the client and the server are secure.
Now, let's focus on the application. When you first open the app, you are at the login page. You have two different options, login or create an account. Our user authentication is handled through Firebase. Once you log in or create an account, you will have access to three different navigation panels. First panel allows you to connect to a server. On this page, a user will be prompted to enter host IP along with the port number. Second panel is the performance panel. Here you can see the time it takes to send out a packet and the time it takes to receive a packet. Finally, the last panel is a profile panel. This will include your personal information along with the date that you joined the application.
For this project, we done our testing using M2 MacBook. We already provided an ARM64 compile version in the repo that contains the API key to access ChatGPT. For the server implementation, we provided two types of transport layer sockets, the TCP and TLS sockets. Indeed, as a bonus feature, TLS won't bring performance improvement, but it can secure user communication between client and server. For now, since we didn't deploy the server to public, so the TLS certificate are all self-signed. You can also find the instruction to run the server in our README file. Now, let me introduce how client can connect to the server. Let's use a TLS server as the example. As the GIF image you can see, first user need to input server's IP and port information and hit the connect button. Once the connection is established, user can see the status on the top bar. To use the voice-to-voice chat, users should also approve the privacy setting on iOS so EchoMind can record user's voice.
In this experiment, we tested the interaction between a client and server through TCP connection. As shown on the left terminal, our client is connected to a TCP server. As shown in the middle terminal, the packets sent between the client and server send unencrypted plain text, as seen in the red boxes. If there is sensitive information being exchanged between the client and server, this would be extremely insecure. If any adversary was trying to gain insightful information to a user's interests or queries, they would be able to have a distinguishing advantage of the plain text with a probability of 100%. Here we performed a TLS security experiment. As shown on the left terminal, our client is connected to a TLS server. The middle terminal then demonstrates how the client and server would interact using TLS. The packets that are sent between the client and server are encrypted, and from a probabilistic polynomial time adversary's perspective, looks like random text. If there would be any sensitive information being exchanged over the connection, the adversary would not be able to distinguish the plain text with greater than negligible probability. Once connected and all the privacy settings are dealt with, there are two ways to interact with EchoMind. First, you can hit the microphone button and record the query. The other way is to simply type out your query. Upon sending, the app will wait for a response from the server. During this time, the user is prohibited from sending another query. Each time a new packet is sent, the network performance graphs will update with the corresponding time to send or receive packet.
So now I'm going to explain how we did our tests. Basically, we tested our server with varying levels of clients connected to it, and then we tested our server with just one connected client, um, 5 connected clients, and 10 connected clients. And we measured the packets sent and received, uh, and the time that it took for them to send and receive for an individual client based on a server having varying clients connected to it. So for one client, we saw that the client's packets sent were around 0.001 seconds, and then there was really not so much fluctuation between the amount of time that a client would send their packet. But for the packets received, based on the varying difficulty of the questions, the response times ranged from a couple seconds to 20, almost 30 seconds. So for example, the question here, I believe, was what is RSA? And for ChatGPT's API, it took almost 25 seconds to give a response for um, what is RSA and its explanation. And whereas over here, it was like, how many days are in December? And this was relatively quick with only a second or two, and it would give a response time. For the 5 connected clients, we saw an increase in the amount of time it took. The packet sent was still relatively the same. So the time that it took for a client to send a packet was relatively the same as before. And then the time received for this question, it's also still what is RSA? And it took almost 40 to 50 seconds to receive a response time. Um, you can see over here, there's some more fluctuations, but the smaller, easier questions where it's like, how many days are in December, ChatGPT could respond almost similar to with just one connected client. And then we tested 10 connected clients, and our results, other than this question right here, were relatively the same. The packet sent actually fluctuates a little bit more, but it's still within reasonable values. And then the packets received, um, we noticed that it was relatively the same as with 5 connected clients, and we felt that actually we observed that the server speeds converge based on um, or the server speeds converge after we uh, connect more clients, and the number of clients that we connect don't scale linearly with the decrease in performance. However, we also did realize that another factor was that ChatGPT itself has inherent bias between its responses. It doesn't necessarily generate the same deterministic response every time to even to the same question. So we notice that between these responses, even though they're the same question, they have different response tokens. So response number of response tokens. So we also had to calculate and observe the fact that ChatGPT itself could have varying response times based on the same question. However, overall, we think that our observations and our testing determined that uh, our server does not linearly depreciate its performance with the number of connected clients. And now we'd like to transition to our demo.
This is the screen you'll see when you first download the app. You have the choice to create an account or log in if you already have an account. In this case, we will create a new account. We will then log out to check if the account was successfully created and added to the Firebase database. Here we see that our login was successful. Here's a demonstration of our speech-enabled feature. You can verbally input a query and the system will convert it into written text. The response will be in text form and will also be converted into spoken words using text-to-speech technology. Hello, who are you?
Hello, I am an AI language model developed by OpenAI. I am here to assist you with any questions or tasks you may have. How can I help you today?
How many days are there in December?
There are 31 days in the month of December.
Thank you.
You're welcome. If you have any more questions, feel free to ask.
Here is a demonstration of our multi-threaded TCP server. On the computer, we are running the server along with one of the clients on an emulator device. To the left, on the phone, we have an external client. To demonstrate multi-threading, we will be manually inputting the queries. You can see that both clients are sending queries and the requests are being processed simultaneously. Thank you for listening to EchoMind, our CS536 final presentation.